In this video, we're going to look at how we would build a circuit like task 8, part 8 in Yenka. Here is the task, and I'm going to switch the screen just now to Yenka. If you want to follow along, this is on page 17 of the Digital Electronics course notes. I'm using the home version of Yenka here because I'm at home, so I'm going to click I'm at home to open up the program. I'm going to go into the Technology tab and select Electronics because this is a part of Yenka we need in order to build a logic circuit. From here, I'm going to select the option New on the left-hand side, and it takes me to the screen where we can build circuits. Now, looking at the task, I can see that I'm going to need 6 inputs and 4 outputs. So I've got a few things opened up, but I'll close them just now, just so we can see where we find things. To find inputs and outputs for logic circuits, we go into lab equipment, to logic, which I've got open already, and we can use either latching or push button logic inputs to represent our inputs, and we use the logic indicator as our output. We're going to use latching logic inputs for this task, so I'm going to put 6 of these onto the screen to represent the different options on our drinks machine that we have in this task. And on the right hand side, I'm going to put 4 logic indicators to represent the 4 outputs that we have in this task. And these are ways of representing ones and zeros. So when we press the input switches, we're switching them to ones. When the output logic indicators turn red, that's indicating there's a 1 there. Now looking at the task, we can see there's a number of gates. In this part of Yenka, we're going to electronic components, digital processing, and then, as I've said in class, there's no real difference for our purposes between the 4000 series and further down the 7400 series, but we've just been using the 4000 series in class. For 2 input gates, we'll find them in the logic gates, and for 3 or more inputs, we'll find it in the 3 plus inputs folder. Looking at the diagram, working from top to bottom, we have a 4 input OR gate, because I can see 4 lines coming in at the left-hand side. Then we've got another 4 input OR gate, so I'll select another one of those. Then we've got a 3 input OR gate, and then lastly we've got a 2 input OR gate. So I'll go back up to the previous folder of logic gates and select an OR gate from there. So we've now got all of the inputs, outputs and components we need for this. What we'll also do is label our diagram as well, and we're given all the labels in the question, so we go into the very bottom folder presentation and we use text. And we can just drag these on here, and I'll do these as quickly as possible because this is not an interesting part of the task. Black coffee. Coffee. Sweet black coffee. The part of the task that takes the longest is typing labels. But it is important because this is what distinguishes this circuit as a practical circuit that does a particular task rather than a series of gates with no specified purpose. T. I find it sweet tea. And each time I'm dragging these onto the screen to add. It's important to label our inputs. We need to know what we're pressing because it's going to help us with any testing within our circuit. Similarly, we need to label our outputs as well. So we've got the 4 possible things our machine can dispense, which are coffee, milk, sugar, and tea. So we've now got all of the components from the picture. the diagram in the question, we've got all of the labels, and then we need to connect things up. Now, start off with the easier bit. To the right hand side of every gate, each gate is connected to an output. So the top output is connected to coffee, second one to milk, third to sugar, and the fourth to tea. Now looking at the left hand side of each, well, the number of lines going into each one is the number of inputs they're going to be connected to from this diagram. And the best way is to look from top to bottom and work methodically. And of course, we can check this with common sense. We know black coffee is coffee on its own, but if we weren't sure what these were, we could follow the diagram. Black coffee connects just to coffee, white coffee connects to coffee. And then if we want to have another connection to milk, we go back to the right-hand side, just to the right of the switch, a box appears, and if we click on it when it turns black, if we click, we can draw another line out. Now, when we're drawing our wires across, if we want to turn our corner, we just simply click, and then we can turn it at a right angle. That's what I've done here to connect it to milk. Sweet black coffee is going to be a combination of coffee and sugar, so I'm going to connect that to coffee, then take another line out here. Connect it to sugar. Sweet white coffee is going to be, well, what we'd expect. It's going to be coffee. I'm just being careful not to join this to any other wire. Milk and sugar. Tea is going to be tea, but it's also milk. It doesn't give us an option for black tea here, so tea is a combination of tea and milk. I'm just be careful to join that up. And lastly, and because it's getting a bit messy at this point, just be extra careful. Sweet tea is going to be a combination of tea, sugar, and then lastly, the last wire we can take out here, milk. Now, see very carefully, I'll bring the wire up here. There's one final connector there. So your diagram might not look exactly like this, depending on how you've routed your wires, but this is what it should look a little bit like. In this task, we've also got two questions. One is to explain what happens when a button is pressed. Do this for at least two selections. This is a little bit like the testing question we have in the TMA. So what the example is in the notes, when I press the white coffee button, the coffee output and milk output will both switch on. And of course, we press this, that's exactly what happens. So in this question, you're being asked to do two more of these. I would say when I press the sweet tea button, the milk output, the sugar output, and the tea output are switched on. And of course, they are here as well. To improve this into the sort of answer that you'd have in the TMA, you'd describe all the possible tests you could have in the circuit. So in the TMA, you have a list of criteria the circuit's meant to make. You should say what buttons you're going to press, what you expect to happen, and then you should record what does happen. And in many cases, I'm sure it will be the case that it does, but if it doesn't meet what the test that expected, that's an important piece of information to record in your answer. The second part of the question in the task is explain what will happen if two buttons are pressed at the same time. And of course, this all depends on what you have chosen for your inputs. If, like me, you have chosen the latching inputs, if we press two things at the same time, so say tea and black coffee, we get a mixture of milky tea and coffee coming out, which is not a desirable outcome. However, if we had selected push button for our input, we wouldn't be able to press two buttons at once, and that's the answer we could give there as well. So this is very much dependent on what you put into your question. And this could also be an example of a TMA type question, which is often about suggesting an improvement to the circuit. So if we built a circuit like this, then we might want to say switching to push buttons or introducing some sort of gates to prevent two outputs coming out at once would be a good improvement of the circuit to stop the user getting a drink that was a mixture of two drinks, which they wouldn't want. So that concludes task 8. There's also going to be a video on how to do this task using the free online logic gate simulator. So if you've watched this, but you're not intending to use Yenka, just look out for the other video covering the same task, but with different software.